Class notes for converting a polynomial from standard form to vertex form. So standard form is what we have here, ax squared plus bx plus c. So if we have our problem written in this form, we want to convert it to a vertex form where we have a and then inside of parentheses x minus h. That is being squared plus k. And another thing that you would want to know to recognize that you'll need is the perfect square trinomial forms there, where you'll be able you'll need to recognize that a squared, it should be a squared plus 2ab plus b squared is equal to a plus b, and that is squared. And same thing, we would need to know this one here, because what we'll have to do is convert it from we will have to use the perfect square. We will have to complete the square rather, and then we'll determine which perfect square trinomial that we have. So the problem that we're working on is 2x squared plus 20 minus plus 20x minus 6, and we that is written in standard form. So we want to start out by grouping our variables, our variable terms. So we take the first two terms and group them. And then we want to factor out the coefficient from the x squared. So 2 is in front of the x squared. We factor that out, and we get 2 times inside of parentheses x squared plus 10x minus 6. The next thing that we want to do is complete the square by taking 1/2 of the x term and squaring it. So the x term has a 10 coefficient. We take that 1/2 of that, which is 5, and square it. We get 25. Then we we add that on the inside of our parentheses, as we can see here. But also remember that we factored out a 2 originally. We did not factor that 2 out of the 6 that we had there. So what we have to do is when we we also take that and subtract 2 times 25 from 1/2 squared of that x term. So this is what we get in that case. Now we have a perfect square trinomial here. And we can now write the perfect square trinomial into into the form that we talked about earlier, depending on what it looks like. So we have x squared plus 10x plus 25, and that looks more like this first one here. So we can change this into a plus b, and with that being squared. And the way we do that is we can take the square root of the first term. So square root of x squared gives us x. Square root of the last term, which is the constant, 25, is 5. So x plus 5 inside of the parentheses squared. We keep our 2 on the outside, and we simplify what we have here. That simplifies to 56. Now we know our vertex. Based on our vertex form, we have a times x minus h, and that is being squared plus k. So we come back here and we look at what we have. Well, we would use the opposite sign here because our formula has a minus in front of it. So the opposite sign is -5. And again, here our formula has a plus there, so we're going to use the opposite sign to write our vertex. Or I'm sorry, we have a plus, a minus here, so we use this sign because our formula originally has a plus in it. So we keep -56. The the graph also shows us that negative 56 is a minimum because our graph concaves upward, and the bottom or half of the graph where the graph changes direction right here is negative 56. So we know our vertex, and then we want to determine what are the intercepts. Well, to find our y-intercept, we let x equal 0, and once we do that, we determine that the y-intercept is negative 6. To find the x-intercept, we let y equal 0. So once we do that, we're going to have to use the square root property here to solve this by getting our x term or our x plus 5 on one side of the equation and then taking the square root of it. So there we see we take the square root of both sides, we get our x plus 5 is going to be equal to plus or minus 5.292. Then we write our two equations to solve for x. So the first equation, we write it with the positive 5.292 and subtract our 5 on both sides to get x is equal to 0.292. And then on the other side here, we use our negative 5.292, subtracting our 5 on both sides to get x is equal to negative 10.292. And we have our x-intercepts there. We talked about our max. We have a minimum because our graph concaves upward. So our minimum is the negative 56 on our at y is equal to negative 56. And